Right. Hello, George.
Hello, guys. How's the good morning? No, good evening. Not in England. How's Melbourne?
Yeah, good. So, George, we've got a bunch of wonderful people here at the Innovation Centre on the east coast of Australia. So a lot of us are Australian, and yeah, basically we've sort of just introduced them to the concept here. A lot of people are business owners and forward thinkers, and I just said that we got you on the line for 20 minutes, and I've already explained who you are. And yeah, take it away. And if anyone wants to ask any questions about the Ethereum Foundation and maybe what they stand for, or any questions, and yeah. And where are you at the moment, George?
Pardon?
Where are you at the moment?
I'm currently in sunny London. Well, I say sunny, it's grey. It's always grey. It's London. Um, but yeah, so I'm the only Ethereum guy in London at the moment. Actually, we've got Vitalik coming down on the 19th for a meetup as well. We'll have to get Vitalik to Melbourne. That'd be awesome. But yeah, so I'm going to try and share my screen. I've prepared a little presentation for you guys. Let me just see if this works. I want to show entire screen. There we go. Share. So basically, yeah, I'm gonna go through the presentation, and then if you want to just ask any questions you like at the end, I'll try and leave a bunch of time so that we can do that. Can you see my screen now? Can you see yourselves?
Yes.
Yes. Okay. Awesome. So let's get. It's not an ideal solution. I'd like to have a little, maybe my face in the corner or something. But is this okay? Can you see everything?
Perfect.
Awesome. Awesome. Let me hide this. So yeah, my name is George Hallam. I am the head of external relations at Ethereum. And that role basically just sees me getting to talk to and speak and reach out to awesome people like you guys who are kind of interested in what we're doing. I do a bunch of PR, I do social media and a little bit of dev stuff, but I'm not a very good dev. I leave that to the PhDs. But yeah, so I'm going to start off with, I think I'll go back and kind of, because we're building a decentralized system at Ethereum. That's at the heart of it. And to say, well, why are you building a decentralized system? You kind of need to look at the issues that exist with centralized services that already exist. So, let's start off with this, look at data silos, walled gardens, things like Facebook, right? So sure, if you have Instagram, you can share your photos on Facebook, they can link across, but that's because Facebook owns Instagram. Otherwise, it's actually incredibly difficult to move your content. Remember, you're generating content on this platform or any sort of tech platform that you're using. And I think it should be much, much easier for people to transport that data across. I mean, at the end of the day, you own it. Sure, it's easy to transfer from Instagram to Facebook, but if you're trying to put that across to Google Plus, not so much. And you could argue as well that, it could be a defensive mechanism. That's why Google Plus wasn't a massive success. But no, it's not an ideal situation at all. Another problem with centralized services is vulnerabilities. So when you have a centralized point of attack, sure, it could be very well defended, but once it is compromised, the entire system is compromised. That's terrible for the users. We see this all the time. There was the JP Morgan hack where they lost essentially every single client, every single customer. Their data was stolen. I wouldn't be surprised if almost all of you guys in the room at some point has had a small piece of your personal data leaked in some sort of hack. I mean, just the other day, personal story, my parents' friends were with TalkTalk. I don't know if you have TalkTalk in Australia, but it's essentially a broadband provider. Anyway, they got hacked, all the data was stolen, and a few days later they were receiving these calls, people ringing them up using the phone number which had been stolen. And because they had all their personal information, they knew that they were having slow internet problems, they were able to basically socially engineer more information out of these poor people, and they had their money stolen from their bank accounts. Now, obviously, thank God that the bank was able to remunerate them, but this is a serious issue, and there's not enough legislation in place, I think, to make sure that companies, centralized services, are protecting user data. Another thing is kind of privacy is unclear as well. Sure, you have these great privacy checkups on, again, things like Facebook or whatever, but is it really that easy to understand what's going on? Is it really, can you see exactly which entity is being able to look at your data? Can you see like which government today has been able to look at your profile and see what you've been browsing? And that kind of comes as a lack of transparency as well. You know, they'll publish, say, we had between 1,000 and 20,000 requests from the government to look into our users' data. They won't say which users, all that kind of stuff. And obviously as well, because one entity controls this huge pool of user data or anything, you know, any other situation, it's open to manipulation. So, you know, at the end of the day, these are people that are controlling these services, and if they can be manipulated, one person, then that can very easily compromise the whole system. And, you know, as I said before, it's difficult to use content with other services. It's difficult to move it across. You're not in control. So I don't really know what that means. So enter distributed networks. Distributed networks are, I wish I could show you, I'm doing a thing with my hands right now. So instead of having a hub and spoke model, kind of like a wagon wheel, which is how sort of centralized networks work, it's more of a mesh or a spider web, whereby you have a node on the network, which is connected to lots of other nodes. And each node has its own sort of level of security, is its own separate entity in the system. And that makes it much, much more secure. Like, sure, you could compromise one node in the network, but that would absolutely not compromise every other node of the network. And, you know, as we move forward, as we get better at, you know, being able to create these secure systems, we'll very quickly overtake and offer a better level of security than anything that a centralized entity can provide. You also have, you know, a much greater amount of transparency and traceability, and that comes through things like blockchain technology, etc., whereby, you know, with Bitcoin, for example, every single transaction that has ever taken place is viewable at any time by anyone for free. And that's kind of crazy, right? I mean, sure, it costs, you know, for an Ethereum gas and Bitcoin sort of a few bits or whatever to make a transaction, but actually reading the network itself in terms of auditability is incredibly cheap. And that's something which is often sort of glazed over, but I think it's a very, very, you know, important facet of the technology. Another thing as well is with decentralized networks, you get synergy between nodes as opposed to these sort of data silos, walled gardens, whereby the nodes that you're connected to generally benefit from you being on the network. And that can happen at various different levels, sort of all the way up to quite sort of a meta level. So imagine if you're using BitTorrent. And BitTorrent has, you know, you've got X amount of seeds and X amount of peers. The more seeds and peers you have, the quicker the file is downloaded. With Ethereum, it works slightly differently. Obviously, you know, the more nodes you're connected to, the better view of the blockchain you have. But at a higher level, there's a lot of synergy between, you know, applications, decentralized applications. But I'll talk a little bit about that later on in the presentation. So yes, enter the blockchain, a distributed network implemented as a global, immutable, shared ledger. And what that essentially means is it's viewable all around the world, it's immutable. Once it's been written to, it can't be changed. And it's shared, and you know, anyone can access it. Access control is through digital signatures. It's open to all, so you don't need an email address. You don't need to be plugged into any other sort of systems other than having a connection to the internet. You can run a Bitcoin, for example, on a Raspberry Pi, or Ethereum on a Raspberry Pi. You don't need to have, you know, all the extra sort of things that we're used to today in terms of interacting with online services. So a well-known example of blockchain is, well, Bitcoin. It's digital, it's uncontrollable, and it's a currency. And it works very well, pretty well, at doing those things. It was invented by Satoshi Nakamoto. I guess he was kind of figuring it out in 2006, 2007, 2008, and then released in 2009. Obviously, Satoshi Nakamoto has disappeared off the face of the earth. Although I think there's a certain Australian gentleman called Craig Wright who might be changing our view on that soon. So we'll see how that goes. But the problem with Bitcoin is that it's really, really difficult, impossible almost, to implement database applications that go beyond, you know, simple monetary transfer of value addition. And it can only really be used as a global ledger. So when you look at it from that perspective, we're starting to understand that blockchains have multiple use cases that go beyond just the remuneration of accounts, the, you know, transfer of value without a centralized entity. And that's where, you know, Ethereum comes in. Yay, Ethereum. So Ethereum was proposed by Vitalik Buterin. He's currently 22 years old. I think he was 19 when he wrote the Ethereum white paper. And he released that at the end of 2013, showed it to as many people as he could get it to. You know, he was already quite a big name in the crypto space. He was the co-founder of the Bitcoin magazine. He wrote PyBitcoin Tools, which is a very prolific Python-based Bitcoin toolset. And he has a few other sort of Bitcoin-related projects to his name. And before Ethereum, actually, he was really interested in colored coins. Because I think Vitalik's a smart guy, and I think at quite an early stage, he understood that there was a lot more potential to blockchains than just being used as this value transfer mechanism. You can do a lot more of them, but you're constrained by the way that Bitcoin was implemented. It doesn't have the flexibility. It's not able to do the value added. It suits the use case that it was built for well, but blockchains can do more. So a little bit, I guess I'll explain what Ethereum is as well. In a nutshell, Ethereum is a new innovation in computing, built from technologies and concepts originally pioneered in Bitcoin. Bitcoin is, as we said, widely understood to be a system for generating a shared world ledger that securely records Bitcoin balances. Ethereum, on the other hand, uses many of the same systems, such as blockchains and peer-to-peer networking, in order to generate a shared world, and this is the difference, computing platform. So it's not a world ledger, it's a computing platform. And that computing platform can flexibly but securely run any application that users want to code. Shared ledgers like Bitcoin included, right? Ethereum is pretty good at doing that as well. And that's kind of, on the face of it, what Ethereum is, and we can talk a little bit more about that as we go through the presentation. A little bit about the Ethereum Foundation as well. So Vitalik created the Ethereum Foundation, which is a non-profit organization, to continue to scale out and build Ethereum. So obviously we had FDev as well, and that was within the sort of Ethereum Foundation umbrella. It's a community-driven research and development project. So the main facets, the most important things to the Ethereum Foundation is education, development, and research. And we're focusing very, very strongly on all those things right now. I haven't concluded much about research in this presentation actually, but if you'd like to ask some questions about it at the end, it's like really, really interesting topic. So yeah, it's a non-profit organization. Everything we build is entirely open source and entirely free, usually under an LGPL or a GPL software license. We raised $18.4 million US during the crowdfunding campaign that was run in the summer of 2014, and at the time, I think it's been beaten by quite a few new groups now as sort of the internet economy grows and grows and grows. But at the time, it was the largest time-constrained crowdfunding exercise ever. And I think that's kind of awesome. Really, really, really cool. And it was done entirely in Bitcoin as well. Obviously, we had to build additional infrastructure to allow sort of the accountancy and that sort of thing. But no, it worked, and it was really, really cool. And that kind of inspired a lot of people to use Ethereum for similar use cases. So Ethereum is actually probably one of the best things about Ethereum is its community. You guys stood right there. Thank you ever so much again for coming. I really, really appreciate it. So there's 250 meetups around the world which are covering Ethereum, and over 40,000 members, which in sort of 2 years or so is not bad. It's not bad at all. We're growing very, very, very quickly. The community is growing, and you have all these wonderful people who are creating incredible applications and contributing to the research and building education platforms. All this stuff. It's really, really amazing. Having the opportunity to watch Ethereum grow has been crazy for me. I can't believe I'm in the position that I am to see this wonderful thing blossoming. So we launched in July 31st, 2015. The Frontier, and that was kind of like a beta network whereby we were aware that there could still be some bugs. We spent a lot of money on security audits with some very world-renowned security auditors and academics to make sure the system is safe. And then we ran through that. We did a lot of testing in that period, and we were able to sort of release the stable release, Homestead, on Pi Day, 14th, on March 2016. So that's where we're now. And the next step will be Metropolis. And so from Frontier to Homestead, that's the migration from beta to sort of the stable release, and from Homestead to Metropolis, that's moving from just sort of like a smaller network to something which is pretty much ready for mass consumption. We're trying to build the easy-to-use user interfaces, the tutorials, to build the information pools, to allow most people to be able to interact with the system and create their own value. So let's talk a little bit about functionality quickly. So Ethereum is built on, well, anything that you build on Ethereum is essentially built out of smart contracts. And as I said before, anyone can create anything with these smart contracts. The only limitation, as it stands, is the gas limit within the system, whereby we basically, so with Bitcoin, you pay per transaction, right? You pay a small amount of Bitcoin to incentivize people to carry out your transaction. Well, in Ethereum, instead of that, we have a system called gas. And what gas does is it pays for computational steps. So imagine if you're running a program, just say on your computer, and each computational step uses X amount of computational power. Well, what we do is we've created a system which means that you pay for each one of those steps. And what that means is that because Ethereum is, quasi-Turing complete, people can't just write infinite loops into the system, spam it, use up all the resources, that kind of thing. That's what gas is there to do, and it essentially remunerates the people who are carrying out the actual running the programs. Again, currently on Ethereum, everything is visible to everyone. You already have a blockchain explorers are different to Ethereum than they are on Bitcoin, because you need to really be able to dive into the code of these smart contracts. And by the way, so smart contracts are these little pieces of code that sit on top of the Ethereum blockchain, and they are these little programs. And bringing them together, you can and sticking a front end in. And what we can talk about use cases as we move through. An interesting thing about smart contracts is that they essentially have all of the power that a real human user would have in the network. So they have their account balances, they have their own accounts, they can speak with other smart contracts, they can remove themselves from the system, they can sort of, it was commit suicide, but we've changed that to self-destruct because it was a bit sort of it wasn't appropriate, so we changed that to self-destruct. But yeah, they're really, really interesting pieces of code. And what this means is, because they're running on a consensus system, if two parties can agree that a piece of code is going to do what it says it's going to do, then you no longer need a third party to act as a mediator or as an escrow. And that creates this trustless system whereby if you can trust the code, you can trust the interactions with other human beings. And it's worth noting that that's never really been a thing before. There's always had to be a counterparty, and this is one of the really interesting things about Ethereum, is that might not be the case anymore. So let's talk about applications. Just to check, sorry, can you still hear me?
Yeah.
Okay, cool. It's disconcerting not being able to see you. So possible applications, name registry. Currently, you have several name registries, or which are spread around the world. The DNS. And if one goes down, then a huge part of the internet is no longer accessible by a large amount of people. But having a decentralized name registry, which is on a system which can't really be taken down, which is, as I said, what's the word I'm looking for? Censorship-proof. This allows a much better place to host potential name registries. Another interesting application is prediction markets. On Ethereum, we have two groups who are building prediction markets. They're called Augur and Group Gnosis. And essentially what a prediction market does is it allows you to bet on the outcome of a real-world event. Now, unfortunately, Group Gnosis is ready, but it's not really generating, not a lot of people using it yet. Augur will be ready soon. I'm really hoping they'll both be ready for the US elections, because my God, that's entertainment. Another great use case is voting systems. So obviously, as I said before, you have each person has access to their own account. You could maybe link, say, a hashed version of a passport to that account, and all of a sudden you have identity tied to an Ethereum account. Only one passport can be tied to that account. If any other hashes of the same hash are on another account, something is wrong. So you have this fully auditable system, which is much better than most of the voting systems that exist today. And so that's very, very compelling as well. As I talked about before, escrow services is another big one. The ability to sort of cut out the middleman, reduce costs. That's a huge business potential for Ethereum. You've got groups like Hitfin in California, which is doing essentially acting or creating smart contracts which act as counterparties in derivative exchange. So instead of having to pay a large fee, you pay a much smaller fee, and the smart contract would actually act as a counterparty in the transaction. Another example would be, say, imagine I was going to sell my house. The deed of my house is being created as a token on the Ethereum network, and once I exchange that token with someone else, or say I'll put it into a smart contract, the smart contract can have the logic whereby if the other party does not move the money into that smart contract within 4 days, then the deed gets returned to me. If the other party does put the money in, but I don't put the deed in, the money gets returned to them. If the requirements of the smart contract are met, then it is exchanged, and they get the deed, and I get the money. That's obviously not the best use case, but it's an example of kind of how they work as a escrow service. Crowdfunding is a really, really big one. So I told you before that we raised 18.4 million US dollars using Bitcoin, but the issue was that we had to build the rest of the system around the Bitcoin blockchain. We weren't able to do it all on the Bitcoin blockchain. Now with Ethereum, because of the smart contracts, you can do entire crowdfunding exercises on the Ethereum blockchain, and this has happened already. There's a company called Digix Global, and what they do is they create gold tokens. They have a vault in Singapore where they have a whole bunch of gold, and you buy tokens, and that tokens is essentially redeemable for the gold in that vault. And what they did is they did a crowdfunding campaign whereby you transfer Ether across, and that is exchanged for Digix tokens. And instead of that having to be a separate system beyond the blockchain itself, the entirety of it was done on the Ethereum virtual machine. And I forgot to mention, the Ethereum virtual machine is what runs the smart contracts on top of Ethereum. So another one, P2P insurance. How am I doing for time? Oh, we're all good. Or have I massively gone over? I think I've gone over a bit, haven't I? I'll speed this up. So a few startups, we talked about a couple. Slockit is another great one. They're doing smart locks. So imagine you're renting an Airbnb. Currently, you have to find a key. You have to, you have to give the key back. It's not a perfect solution at all. Imagine if you had NFC chip in your phone and you have a token which is redeemable to unlock the door. So the owner of the Airbnb, you transfer the money to them. They transfer you the token. The token can then be retrieved after a specific date, which means you no longer have access to that Airbnb, and that cuts down costs massively as well. And then to the point I was going to make earlier, network effects exist between all of the applications that are built on Ethereum. So if you have, say, Maker, which is a stable coin, a coin that is pegged to a basket of derivatives and stocks and shares or whatever, it remains at a stable price. You could use that to pay for your smart lock. So each entity there is creating value and benefiting from the other one's existence. And that's what I was talking about before, is the synergy that exists on the Ethereum network. Is generally, everyone benefits from everyone else's existence. Here is a website called, what's it called? DApps. Daps.ethercast.com, and this is essentially a list of all the applications that people are building on Ethereum already. It currently has 198 entries, which is pretty cool. If you want to find out more about some of the apps that are being built on Ethereum, please do check it out. Some really interesting ones. Grid Singularity, Transactive Grid, as I say, Group Notice, Melange, a whole bunch of stuff for KYC, AML, and all that stuff too. So Mist is the DApp browser. So you're putting these smart contracts together, you're putting a front end on it, and all of a sudden you have a decentralized application. What we want to do with Mist is make it very, very easy, very, very safe, and very, very secure for people to interact with this system. So essentially, the premise is that my mum will be able to go on this, and she doesn't know anything about computers, and she'd still be able to interact with the system in a friendly manner because of the way that the applications are built. And they're safe because you'll have a little thing in the corner which says that this app has been audited, it does what it says on the tin, all that kind of stuff. We want to protect people on the network. Finally, for any developers, this is Mix. This is our IDE that we're building. It helps you build your smart contracts. It has testing, all that kind of stuff. And I really recommend you checking it out. It's pretty awesome. Sorry for running over, guys. Yeah, so I'm George Hallam. That was my little presentation. Thank you ever so much. Right. Can your screen sharing? How do I turn the screen sharing on?
Does anyone have any questions? Just go for it. Got a question here? Are you on the phone?
There we go. Hello, guys. Ah, you're all sat down. Sorry I was so long. I get lost in the Ethereum.
Did I? Still there? There we are.
Yes. Any questions?
There we go. We had.
Okay.
Can you hear us?
Good here.
Perhaps if someone close to the laptop repeats the question, or the screen, or wherever.
Can you hear us? Was the first question?
I can hear you if you're close, yeah.
I just got to find you.
Swipe left and right.
No.
Oh, at the top. What's that? There it is.
There's only one desktop.
No, when you swipe down, it's up at the top.
Not there.
What was your question?
The question is Ethereum
just change
actively
it to-
working on a platform where you can buy Ether straight from, say, US dollars or something, so you don't have to buy Bitcoin and then transfer it, then buy Ether from Bitcoin?
George, did you hear that question?
No. Can you repeat it? Sorry.
Yeah. She was asking, is there currently a system where you can buy Ether directly instead of having to get Bitcoin first, so that you can have a US dollar or AU dollar transfer directly to Ether?
The best thing to do would to go on. I mean, I don't really follow the whole exchange thing too much. The best thing to do would be to go onto RF Trader, which is like the Reddit page for Ethereum trading. That's a pretty awesome place to figure that kind of stuff out. I think there is a US and Australian dollar pair. I'd have to Google it quickly. Was it Australian?
BTC.
Markets have just added Ethereum.
Oh, okay. Okay.
BTC markets have just added Ethereum.
Just added Ethereum.
Yeah, and I think there's another one called Coin, Quoine, and they have a F Australian dollar peg as well, but I don't know if it really has any volume. Yeah, unfortunately, it's you know it's still quite kind of early, and you know we're not focusing too much on that right now. But yeah, you should be able to pick it up from there. Any other questions? Anything about sort of future research, scalability?
Chris?
Hi, George. I would have a question about the blockchain, and I understand on a central server it's a database and it keeps track of transactions. I'm having trouble understanding how the blockchain represents where data is stored. Okay, so all transactions throughout history are stored there. But how does that work? I've heard that in Ethereum currently every node has every transaction. That's obviously not a scalable sort of approach. So yeah, how does that, without getting too technical, but conceptually?
I can do the hand movements now, so it's all good. Right. So yeah, essentially, so if you look at the Bitcoin blockchain, I think it's maybe like 10 gigabytes or whatever, and same with Ethereum. We're getting pretty big, obviously much quicker because there's a lot more going on it. But yeah, so every 10 minutes on the Bitcoin blockchain, a block is added, and inside that block is all of the information that is all the transaction information which has occurred in the last 10 minutes. That block is then agreed upon by the miners and then propagated across the entire network, so all the nodes. And as you say, right now with the blockchain as a database, every single node on the network carries a copy of that database, and they're all in agreement of the state of that database. So imagine you'd ever use Google Sheets or like an Excel spreadsheet. Imagine each one of you in the room had an Excel spreadsheet and you had loads and loads of numbers on it, but you're all in agreement of what those numbers were. That's how a blockchain works. It's basically a database that everyone agrees upon its state. Now, obviously, that was how Satoshi Nakamoto originally envisioned the blockchain, and it's not scalable, as you say. There's no way. Like, if you're going to have just like my little MacBook running the entire transactive, computational needs of the entire world, it's not going to happen. So realistically, you have to start looking at other options whereby not every single node validates every single transaction or every single action that happens on the blockchain, and that's where something called, well, this is what we're looking at anyway, called sharding comes in. And I don't know if you know. So imagine you have the best analogy I've heard for this from Vlad Zamfir, who's the guy who's building Casper and doing all of the scalability research at Ethereum. So imagine, like, in 1998, you had a computer and it had a CPU, and that CPU runs one thread. It just goes up, and computation, whatever is needed to be done on the computer, is queued up and has to go through that one thread, which is kind of the same premise as a blockchain as it stands now, where every single node has to do every single piece, carry every single piece of information. Now, then we started getting like dual core processors, quad core processors, all this new parallelization of computing, and that meant that instead of having things running on one thread, things could run on 4 threads. So you're having the same amount of power for the chip, but you can essentially do 4 times as many things. So imagine the same thing. That's essentially what sharding is, whereby you'll have a group of nodes that will be a shard on the Ethereum blockchain, and those nodes will run a specific set of computations, but they won't have to be run by every other single node in the network. So all of a sudden, you can have like small groups of nodes which have like sort of a split. And this is where like the really complex cryptography and stuff comes in, the state root, and Merkle trees, and this kind of stuff. But yeah, essentially, you can have compartmentalized elements of what's going on, which means that and sure, and it all goes back to like a state root. So it all has like imagine like a little tree which goes down like that, and then you have all the branches at the bottom. And that's essentially how we're going to scale, is with sharding. So we're moving away from the idea of every single node having to run every single transaction, and instead having groups of nodes that run some transactions. And then you can have, say some people in that group of nodes don't agree, they can bring in more nodes to have like a sort of court of justice, whereby say this guy's wrong, and everyone else can then say, well, we'll look at this, and you're right, he's not wrong. Here, have some money because you reported him, that kind of thing. So we create some really interesting incentive mechanisms to create this massive system which can scale and can do millions of transactions per second. We've got the modeling; it does work. We're just kind of trying to figure out how to build it really safely and securely now. And I guess another point on that would be the move towards Casper. So proof of stake, proof of work, sorry, it serves a purpose. It's pretty cool. It's essentially virtual gold mining. It's really energy inefficient. It's potentially going to kill the planet. I think by 2020, Bitcoin may well have the same energy requirements as Ireland, which is not too cool. It's not a good way to, if you're only securing. I mean, even now, it's like ridiculous the amount of power that goes into just doing one transaction. It's pretty awful. So we want to move away from proof of work to proof of stake, which is essentially virtualizing gold miners, virtualizing proof of work, so it's virtual gold mining. So you're virtualizing the proof of work mechanism by staking down deposits. So imagine proof of work is you're staking computational power and electricity on finding the next block. Instead of proof of stake, you're basically putting down a stake, and that's a deposit. And as long as you're adhering to the requirements of the protocol and you're not trying to be a bad actor, you will receive back your deposit and potentially some more money as well, which is the incentive mechanism to run this system. And as well, because of things like other elements as well, we can bring the block time down to sort of sub-second. Right now Bitcoin is 10 minutes, Ethereum is 15 seconds. And we think we can go below sub-seconds, and to really have a network. Right now it sucks if you ever paid for anything in Bitcoin. It's like, I'll just wait for an hour and make sure that the transaction's gone through, and it's not going to be double spend attack. Even with Ethereum, it takes about 2 minutes to have the same level of it's stuck in the network. It's not going to change, but we want to bring that way down. So that's also something that we're working on.
Cool.
Does that answer your question?
Yeah, that was good. Lost me for some of that, but that's okay. I just have one kind of follow-on one, which is, would it be correct to say that conceptually, Ethereum or any blockchain model is dependent on a continual growth in resource of computing power to the network? Like, is that a necessary thing? Simply because the more history that is there, the more requirements are there, I would assume.
Right. So you're saying like more hard disk space, more computational power, that kind of thing.
That's right. It seems to me that it would always be necessary for the network to grow in terms of computer power for it to continue to operate.
So I guess that's it's an interesting point. So what we're looking to do when we move to proof of stake is, instead of is to basically aim to incentivize the system. So there's always around about 250 stakers on the network, and there's from a pool of maybe 1,000 different groups or people who want to take part in the staking mechanism at any one time. The system will choose as like a random lottery 250 of them, and they will then take part within the staking of that. Now, because of that, and because of the amount that will probably be expected to stake, those systems that they'll be running on will actually be quite powerful. And most computers won't have to hold the whole blockchain, because they'll have a light client, and they won't have to run every computation as well, obviously, because it will be running on sharding. So I think overall, yes, the network will need to continue to grow until a point where humanity starts shrinking for whatever reason, global nuclear war or famine or God forbid any of those things. But yeah, that's the network will continue to grow and grow and grow and grow. One point to make though is, like, at the current rate that the Ethereum blockchain is growing, you could spend about $300 for a 2 terabyte hard disk, which would last for 500 years. So like that space requirements, when you really think about it in terms of the people who, because that's the thing, like standard people, if I'm just using my phone won't need to hold the entirety of the blockchain. It'll be a light client, which will just make sure that it's looking at the right thing and it's very secure and everything. But only the stakers who have these, they'll have to. That's another thing as well. So we're looking to make it so that people really need to create special systems to make sure that their computers are always doing the correct thing. You have like maybe several servers in connection, which will be validating what the other servers are doing to make sure that it's always going to be doing the right thing within the protocol. So yeah, does that answer your question to an extent? I think yes, the network will need to continue to grow. But I think it will be much more sustainable in terms of energy and stuff compared to, say, other proof of work-based networks.
Thank you.
I've actually got a follow-up question to that. George, the amount of systems that we are relying on that are not in, that society is currently using in comparison to a distributed now you're talking distributed mechanisms that are also decentralized with the next generation. It seems to me that if we were to compare apples to apples, you'd have a massive amount of what I'll call classic cloud computing infrastructure that's being underutilized and still using up power around the world, where when we're running the blockchain, we're actually using active compute cycles in a much more limited hardware-based ecosystem. I mean, if you're comparing data centers to handle 100 people's stuff compared to everybody running the blockchain on their phone, actual energy expenditure would be a lot less, wouldn't it? Or am I missing something?
No, I mean, I think that's very much the case. Another point to that is Ethereum is not meant to be like a global supercomputer. It's not supposed to be like, analyzing weather data or I don't know, trying to figure out which protein is going to lock into another protein so we can cure cancer. I mean, I wish it could do that as well, but it can't. But what it can do is it can incentivize mechanisms. Like there are, you have all these big supercomputers, data centers around the world, and currently, they're not connected because there's no incentive mechanism for them to share their computational capacity. What you can do with Ethereum is you can create your own tokens, create your own supercomputer coin, and then you can basically, as long as you've got like a fast connection between them, you can buy and sell computational cycles from those kind of things. There's actually a group who are doing this, the Golem project in Poland, and they're kind of working on that. So yes, I think Ethereum is I guess more energy efficient perhaps than some, or in the long term it could be more energy efficient than some of the systems that exist today. But it's also worth noting that we can make the whole system, a global system, more efficient as well. Like cutting out the middleman, reducing waste. I don't know if you guys saw the Brooklyn solar energy project.
We were just talking.
Yeah, so right, you can have it's the same mechanism. So you're buying and selling electricity, you're buying and selling computational cycles. Any sort of situation like that where currently there is no entity that sits in the middle, or there is an entity that sits in the middle which is prohibitively expensive, that can be taken down and replaced with a mechanism on Ethereum. And I think that's really compelling. Very, very cool stuff.
Cool. Anyone else have a question? Francois?
Hello, Francois.
How are you?
Well, What happened to your arm?
Don't ask.
Okay.
Yeah. I have a bit of a concern, and that's around the speed of processing on, well, blockchain or Ethereum networks or anything like that. What's the optimal, let's call it transactional processing speed that would be possible? Would this ever be possible to be used in a real near-time kind of near real-time kind of environment? And if you can just quantify what you mean by near real-time.
In what sorry?
Can you quantify what you mean by your definition of near real-time computation?
Oh, near real time. So this is like, I guess, like milliseconds, right? Like, you know, kind of ping speeds that you would expect just from any normal website. Is that real time enough?
Yeah.
Because I think that will be attainable. So we have a 4-year kind of research and development scalability roadmap. We expect to get to the point where we will just be able to scale indefinitely. If you just add more nodes to the network will be able to just handle everything. I mean, hopefully in 2 years we'll be able to do 100,000 transactions per second. Now, knowing how research and development works, maybe 3 years, but we know that we can do it. But still, like 100,000 transactions per second isn't awesome. Like, you know, if you're going to be, if Ethereum is going to be what it needs to be, it will have to do millions of transactions per second. But that's where the sharding bit comes in, because imagine it's not the system as a whole would be doing it, but it's only the smaller shards, which are, and obviously you can just add more shards.
So you're talking node level transactions would be in the millions per second.
Yep.
Wow.
Yep.
Okay.
And you know, based on, you know, increasing internet speeds, all that kind of thing, like, you know, you've got Google Fiber rolling out across America. You know, places like Romania have like awesome internet. Maybe the UK. I don't know how the internet is in Australia. It's pretty crap in the UK. But yeah, oh yeah, maybe maybe we'll catch up eventually. But yeah, so like, you know, that's going to be the limiting factor, is the amount of fiber that they can lay down to you know, increase the speed of the global network. But it's also worth pointing out as well that Ethereum is not meant, as I said, it's not meant to be a supercomputer. It's meant to do like the small back end kind of stuff, and there will be circumstances where, I mean, do you guys know Ripple?
No.
Heard of Ripple? Ripple is like another quasi, it's not really a blockchain, but it's kind of, you know, in the space, if you will. And they had a project called Codius, and the premise of that was where you can essentially use servers. So you have a bunch of servers, and you run the same thing on 4 different servers, say, and then you can take the average of those 4, and you can say, all right, well, we have much greater certainty that this same thing has happened. Like a system like that would be really, really cool for a lot of the larger computationally intensive things that, you know, Ethereum wouldn't want to or wouldn't be able to do. Unfortunately, they can do it, which really sucks. But yeah.
Cool. Anyone else?
I have a little question. Can viruses be written and spread through the system?
Can viruses be written and spread through the system?
So, no. I mean, you could write a nefarious smart contract. I mean, like Vitalik actually made a post on this the other day where someone had created a smart contract that said it did one thing, when actually, and then what they've done is they've done a really sneaky piece of coding where it actually didn't do it. On the face of it, if you're just glancing at it, yeah, sure, it does that. But when you really look into it, it doesn't do that at all, and it essentially just steals your money. I guess you can. I don't know that I call that a virus. We have the whole of Geth, which is, or Eth. The clients that we build are sandboxed, so there's no way for data to exit the Ethereum sort of portal, if you will. Think along the terms of like Google Sandbox, which is actually pretty crap. Like, you can get a lot of viruses from your browser, but that times like 1 million. And because, you know, it's not the same amount of, you know, craziness that is going on. It's almost, as far as we're aware, I mean, this is what we spent like hundreds of thousands of dollars auditing the network to make sure that someone's not just going to be able to write a smart contract which can just compromise your computer. So no, as far as I'm aware, it is essentially impossible.
And you
could happen, anything can happen in computing, but no.
So the end user sees every smart contract they interact with.
So no, this is the thing, right? So I was talking about Mist, you know, a little browser, kind of like a Google Chrome for dApps. The premise of that is you have a little circle in the corner. And if you're a decent, if you're, you know, sure. So it's all about defaults, right? So if an app hasn't been audited and it hasn't got like a little green circle next to it, then by default we'd say that it should be very difficult for a user to interact with that application, and they should be made aware of the fact that it hasn't been audited, it could be doing something nefarious, and you know, unless they have the ability to actually look at the code and read it, they probably shouldn't be interacting with it, or unless, you know, they have some friends or whatever. So we want to create this system where it's really easy to know that, you know, something is going to do what it says it does. And what this leads to is the idea of incentivizing auditors to take a look at the code. So imagine you're a DApp developer, you pay a very small amount of money to these various different auditors. They look through the code and they say, right, this does what it says on the tin. Now, one guy could make a mistake, but if you've got 10, 20 different groups that, you know, have a strong reputation, their reputation is tracked as well based on how correct they are, then you have a pretty good idea as to how safe and secure a decentralized application is. And then you can then maybe bring in other metrics as well, such as the amount of social media that a particular company or group has. You know, you can bring all these different things in to create a score, a number, a color, some qualitative information, which will allow the users to make an educated decision as to how they should interact with that application. Does that make sense?
Cool. Yes.
So an example of this, which is already happening is Ethercamp. Roman Mandalio, he's the guy that builds the Ethereum Java client. He's a pretty awesome guy. And yeah, he essentially does that service now. He runs a block explorer called Ethercamp. And he always asks people, it's like, look, you know, put your code on our block explorer and let us validate it, and then people can see that, you know, the code is correct, and, you know, it's not going to be nefarious, it's not going to screw you over. And yeah, hopefully that will grow. And, you know, another thing to remember as well is like, this is like super early days. Like, think internet 1994. Like, we've got a long way to go.
Cool.
Anybody else?
Everybody good?
You want it very comfortable.
Thank you so much for your time, George. I'll have Tom come. There he is.
Yeah, thank you very much, George, for your time, mate.
Oh, no worries. Absolute pleasure. Thank you ever so much for having me. You know, live for this stuff. It's such a pleasure to be able to speak to you, wonderful people. And yeah, if you have me again in the future, I'd be happy to put some more information together. Maybe I could focus on use cases, or focus on research, focus on, you know, whatever it is that you guys would want. Just feedback to Tom, and I'm sure he'll let me know. But yeah, thank you very much, guys.
Cool. I just want to ask you one more question. We're about to at 8:30 have Arthur on the call. Is it for Arthur Falls from Consensus?
Oh, okay. Yeah.
What's your version of Consensus and what they're doing?
So Consensus is essentially a DApp development house. That also does have some core protocol dabblings in their Haskell client. I think Consensus is absolutely awesome. It's founded by Joe Lubin, who's one of the original founders of Ethereum. They are huge. They're like 65 employees already. They're by far like they're one of the largest companies in the crypto space, let alone just in Ethereum. And they're really, you know, they're really exploring tons of use cases. They've got a great approach where essentially they cook a load of spaghetti, put it up and throw it at the wall, and then see what sticks. And it's going to work really well for them. Like, they're taking the risks, they'll see the rewards, I think. So yeah, I think Consensus is really cool.
Cool. All right. Thank you very much.
All right. Catch you later, guys.
Thank you.
Bye.